So today we're going to talk about solving trigonometric equations, and we're going to do this three different ways. The first way we're going to do this is we're going to use the unit circle, and then we're going to use what's called the reference table, and also using reference angles. And then finally we'll do an example of how we can use your calculator, which we've already done. So let's look at the first example here. And so we want to use the unit circle to solve the equation for x. And here's our equation, sine of x equal to 1/2. So remember, when you're trying to solve an equation, you're looking for the value of x that when you take the sine of it, you get back 1/2. And so if you look over here, you can use the unit circle. And so remember that the input is the cosine of the angle, so cosine of theta. And then the output is the sine of the angle, so sine of theta. And so if we have sine of x equal to 1/2, we're looking for when the output is 1/2. And so right here, the output is 1/2. And so we get one answer to be pi over 6. So x is equal to pi over 6. And if you look carefully, you'll see there's actually one more answer. Over here, the output is also 1/2. And so a second answer would be 5 pi over 6, because that's that angle there. So x equals 5 pi over 6. And now if you think these are the only two answers, because you look around and you see there are no other outputs of positive 1/2, you'd be wrong, because there are more. So remember, when you give one angle, like pi over 6, if you go all the way back around again, right, you get back to the angle where you started. So here, you can add any multiple of 2 pi. So we write 2 pi n. So if n was 1, right, the angle, right, pi over 6, would be right here. But if n is 1, you go an extra 2 pi, so you go all the way back, and you get back right where you started, right here. Or you could add another 2 pi, and you go around again. That's if n is positive, so if it's 1, 2, 3, or 4. If it's negative, you go the other way. So if it's -1, you'd go start here and go all the way around and wind up back where you started. So n is an integer. So n is an element of the integers. Remember, the integers over here, z, these are the nice numbers, 0, 1, 2, ... and then also the negative numbers, so -1, -2, and of course ... Right, and these are called the integers. And the same thing happens down here. You could add any multiple of 2 pi, and you wind right back up where you started, and n is an integer. So this is all of the possible solutions for x. And you can even check this. So for example, if you have your calculator, you can take it out. And let's take the sine of, and let's do second pi over 6. And just because you may not believe me, let's add 2 times pi times, and let's do 56. And you'll see I do get back a weird number. Now, if you get back this number, I should get back 1/2, right? Now, what could be wrong with my calculator if I don't get back a 1/2? Well, let's hit mode, because I bet you I'm not in radians right now. I'm in degrees. So if you're not in radians, right, my answers are given in radians, not given in degrees. I won't get the right answer. So let's put myself into radians. So notice I hit mode, and I'm in radians now. And now if I just hit second enter to pull up that last entry, and now if I hit it, I get 0.5. Right, so it's really important that you make sure your calculator is in the right mode, and in particular in radians versus in degrees. All right, so using the unit circle to solve trigonometric equations is relatively easy. Something that's a little bit harder to do is using reference angles. So in this problem, we want to use reference angles to solve each equation for x. So we're going to do these one at a time. And in order to use reference angles, you're going to need a reference table. So one of the issues with using the unit circle is it's hard to recreate the unit circle. So unless you're given the unit circle, you typically can't use it. So we have to have another technique that we can use to solve trigonometric equations, and this is the technique that we typically do use, and it's called using reference angles. So let's make the reference table real quick, and you should learn how to do this. It doesn't take too much to do. So you have 0, you have pi over 6, you have pi over 4, you have pi over 3, and you have pi over 2. So these are called the reference angles. And really, this is 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And then we can take the sine of these angles, so sine of theta, so let's put theta above here, and cosine of theta. And all you have to remember is that the sine of 0 is 0. And if you remember that, the reference table is really easy to make. You start square root 0, square root 1, square root 2, square root 3, and square root 4. And these are all divided by 2. So divided by 2, divided by 2, divided by 2, divided by 2, and divided by 2. And the cosine of theta is exactly the same, but you write it the opposite way. So square root 4, square root 3, square root 2, square root 1, square root 0. And these, again, are all divided by 2. So divided by 2, divided by 2, divided by 2, divided by 2, and divided by 2. And you can simplify a lot of these, like square root 0 over 2 is actually 0. Square root 4 over 2 is actually 1, because square root of 4 is 2, so 2 over 2 is 1. So you can actually simplify them a bit, but I typically just leave them like that and use them. So if I want to figure out when the cosine of x is equal to 1/2, I do not want to use the unit circle, even though I have it on the last page. What I want to do is try to use this reference table and combine it with a nice user interface of the unit circle. So what do I mean by that? So I don't want to just draw the unit circle, but all I want to do is draw the x and y axis and then write all students take calculus. And so what this means, ASTC, all students take calculus. It's an easy way to remember what to do. Other ways to remember this is Alvin, Simon, Theodore, Chipmunks, but I like all students take calculus because that's how I was taught it. And so what this means is if you have an angle in this first quadrant and you take the sine, cosine, or tan of it, it'll be a positive number. Whereas if you have an angle in this quadrant and you take the sine of it, it'll be positive, but the cosine and tan of an angle in this quadrant will be negative. Down here, if you have an angle in this quadrant, the tan will be positive, but the sine and cosine will be negative. And over here, the cosine of an angle in the fourth quadrant will be positive, but the sine and tan will be negative. So when I look at this problem, cosine of x is equal to 1/2. I see the cosine is 1/2. So that's a positive number. So what that tells me is that I am in this quadrant, but not this quadrant, and not this quadrant, but I could also be in this quadrant. So the angle could lie in the first quadrant or the fourth quadrant. And it's really because of the unit circle, because remember how the unit circle works for cosine. It's the input value, and the input values are positive on the first and fourth quadrant. That's why I say this is a nice user interface for the unit circle. So what I'm going to do is I'm just going to draw my angle. I have one here, and I have one there. And then I need to draw my reference angle. So my reference angle is the smallest angle I make with the x-axis. And I have one on top here and one on bottom. And it's easy to find out what that reference angle is because I know the cosine of x is 1/2. So I come over here, I look for 1/2, and if you look above it, you see there's pi over 3. So my reference angle turns out to be pi over 3. And down here it's the same thing, pi over 3. And there's a 3 there. All right, so my first angle would simply be x equals. And so my first angle here, let's use a different color, let's use green. So my first angle is just right here. And so that's pi over 3. And just like before, you can add any multiple of 2 pi to it and get back where you started. So 2 pi n. Right? N is an integer. Right, I usually tell students this is sort of like telling time. It's like you're on the hour, and every hour you go around, you're on the hour again. So same thing here. If you're on pi over 3 and you go full circle around, full 2 pi, you get right back where you started. And then the second answer, it's a little bit harder to see, but it starts here and it wraps all the way around right there. And I want to figure out that angle. So that angle, the idea is wrap all the way around. Go 2 pi around. So if you go 2 pi around, and then to get that blue angle, you just go back pi over 3. So go back means minus pi over 3. So we're basically just recreating the parts of the unit circle that we need. And so now this is, remember, 2 pi over 1. So I'll multiply top and bottom by 3 to get a common denominator. So 6 pi over 3 minus pi over 3. So 6 of these minus 1 of these is 5 of these. So I get 5 pi over 3. And so my second answer will be equal to x equals 5 pi over 3. And I can add any multiple of 2 pi. So 2 pi n, again, n is an integer. So element, right, this symbol here looks like an e. It means element of the integers. All right, and that's my complete solutions, set of solutions here. So we put a little box around this. And again, you can test your answers simply with your calculator. Just hit cosine. Make sure you're in radians again. And let's just hit cosine of 5 second pi divided by 3. Oops, divided by 3. And if you get out 1/2, right, you know that part's right. You can check pi over 3, and if you get that out, you know that one's right. So you can check it with your calculator. But again, you have to do it by hand. And this is how you do it by hand. Now, if you're given the unit circle, you can use it the other way. But if it says use reference angles, remember, you have to use reference angles. All right, let's take a look at the next problem. And so in the next problem, and I'm going to rewrite it, I think, to give us some more room. So right here, I'll rewrite this. This is problem B. And we want to figure out when is the tan of x equal to -1. All right, so on this problem, I can actually figure out the quadrant the angle is going to lie in. Again, I'll write all students take calculus. And because this is negative, I know what? Well, I know it can't lie in the first quadrant. The angle can't, because the tan of angles in the first quadrant have to be positive. So it can't be in this quadrant. Now, it could be in this quadrant, because only the sine is positive. But it can't be in the third quadrant, because if you have an angle in the third quadrant, the tan of it's positive. Well, or it could be in that quadrant. So what I'm going to do now is I'm going to draw the reference angle. So here's my angle. I'm going to draw the angle. So here's my angle. And I'll draw the angle on the other side, and it actually makes a straight line here, which is nice. And then I got to figure out the reference angle. So let's figure out the reference angle. So I need to figure out the reference angle. Right, this is the angle that when you take the tan of it, right, you get out, the sine doesn't matter for the reference angle, so you just get out 1. But you'll notice that I don't have a tan in my table here. So what I need to do is make this third line, the tan of theta, which is easy to compute if you wrote sine of theta on top and cosine of theta at the bottom, because remember, what's the tan of theta? It's just the sine of theta over the cosine of theta. So we talked about this when we did the right triangle trigonometry. So you just take this number and divide by that number. And so that'll be 0, because this is 0 divided by 1. This one will be easy. This is the same number. So this number divided by that number, since they're the same, that'll be 1. I'm going to skip this one. And then this one, if you take this divided by this, well, this is dividing by 0, so we say it's undefined. When you divide these two numbers here for this entry, it takes a little bit of work. So up here, maybe we'll do that. So you have square root of 1, which is just 1, divided by 2. And you're going to divide by square root of 3 over 2. Now remember, when you divide by a fraction, you multiply by the reciprocal. So that's 1/2 times 2 over root 3. And so here, the 2's will cancel. And you'll get 1 over root 3 out. And so if you want, you can write 1 over root 3 down there. But most of the time, books like to rationalize denominators. So you'll multiply top and bottom by root 3. And what you get is root 3 over 3. And so right here you can write root 3 over 3. And then when you do this division, you do it the other way. So instead of having 1/2 on top, you have 1/2 on the bottom. Instead of having square root of 3 over 2 on the bottom, you'll square root 3 over 2 on top and divide it by 1/2. And if you do this one, it works out real fast. You multiply by the reciprocal and you just get back root 3. And so this one is root 3. Now we're looking for the reference angle here. When you take the tan of it, you get back basically 1. You ignore the sign. And you can see here, here's 1. And if you look above it, you have pi over 4. So that means the reference angle right here is pi over 4. Again, we're just recreating the part of the unit circle that we need. And so if we want to say what x is equal to, how do we do this? Well, we have to find the actual angles here. And there are 2 of them, but in this one it's kind of interesting. You only need 1 of them. Right? So we want this green angle right here. And to find that out, the idea is go all the way around here, which is pi, and then go back pi over 4, so minus pi over 4. And we can compute that angle. And so what's that equal to? Well, remember this is pi over 1, so we can multiply top and bottom by 4 and get 4 pi over 4 minus pi over 4, which is simply 3 pi over 4. And so that green angle is 3 pi over 4, and so my first answer would be 3 pi over 4. And now you can add any multiple of 2 pi and get back where you started, but this one has some nice symmetry to it. Instead of adding 2 pi, if you add pi, you get to the next angle right here. And if you add pi again, you get back where you started. And you add pi again, you get to the next angle. Add pi again, you get back where you started. And if you add negative pi, you get to that next angle. Add negative pi, you get back where you started. So this would be plus, instead of 2 pi, you write pi n, where n is an integer. And this will be all the possible answers to this equation. Right, so notice in these equations, you typically don't just get one answer, you get an infinite number of possible answers. Okay, let's do the last one. And so on the last one, kind of bring everything together here. What do we have? Let's just write it right here. I'll just copy it down. So you have the cosecant of x is equal to negative 2. All right, now the problem with working with the cosecant of x is we don't know how to work with it. We really only know how to work with sines and cosines, and I guess we can work with tans if you make that extra entry in this reference table, right? So remember, this is the reference table. It's called the reference table because it gives you the values for sine and cosine using the reference angles. Okay, so let's convert this to sines and cosines. So the cosecant is 1 over, and I always remember about opposite letters, so if it's C, it's an S. So 1 over sine of x equal to negative 2. And then if we flip both sides, right, this will tell us what? So I'm just going to flip this side, and this is, remember, negative, it's really negative 2 over 1. I'll flip that side, and so this tells me sine of x is equal to negative 1 over 2. And so now I've transformed the problem into something I can actually solve. And so I see the sine of the angle is negative. So again, I can just recreate the part of the unit circle that I need by using all students take calculus. And so I can't be in the first quadrant. So let's put an X through there, because the sine of that angle in the first quadrant will be positive. I can't be in the second quadrant because it says S there, so that means the sine of an angle in this quadrant is positive. So that tells me that my angles must lie in the third and fourth quadrant. So let's draw them. There's an angle. There's an angle. And I need to find those reference angles again, which actually is pretty easy to do. I'm trying to figure out, when is the sine equal to, and I don't care about the negative sign right now, equal to 1/2. So you come over here and you see 1/2, and that's pi over 6. And so this first answer is pi over 6. That's that little angle there. And this angle is exactly the same, so it's the reference angle here is pi over 6. And then to find the actual angles, let's draw them. So you start at the x-axis. So I want the angle that starts here and ends right here. And so again, it's kind of like telling time. It's like you go halfway around and a little bit more, like 10 minutes more. So it's like 40 minutes altogether. So halfway around is pi. and then you go an additional pi over 6. So you add pi over 6 to it. And so I use my ability to compute with fractions. So pi is really 6 pi over 6 to get a common denominator, plus pi over 6, which means that first angle is 7 pi over 6. So right here, I'll write x equals 7 pi over 6. And then, of course, plus 2 pi n. N is an integer. And then for the next angle, let's use a different color. Let's use blue. So again, we start here at the x-axis, and we go all the way around to right here. And so that angle, the idea is go all the way around to 2 pi, and then go back pi over 6. So 2 pi minus pi over 6. So again, I'm using the picture. I can see in the picture, if I go all the way 2 pi and back pi over 6, I'll get this other angle right here. And so that's going to be equal to, I'll multiply top and bottom by 6 and get 12 pi over 6 for the first term, minus pi over 6. And that's equal to 11 pi over 6. So my final answer here would be x equals 11 pi over 6 plus 2 pi n. N is an integer. Now a common question, so let's put that in a box. A common question that I often get is, how do you know when you add pi n instead of 2 pi n? And the answer is, it depends upon the picture. Right? It's too difficult to give you cases or too many cases, but if you look at the picture, you can see if you add pi, you get back where you started. Whereas if you try to add pi to this angle here, you get back to the first quadrant, which is not where you started. So you can't just add pi and get an answer to your problem. All right, so let's look at this next one. We kind of combine some things we've done before with the new stuff. So we want to solve this equation, and we only want to solve it between 0 and 2 pi. So we don't want all the answers. We just want the answers that are going to fall between 0 and 2 pi. And so when you work with this equation, the idea is you want to see that they actually have something in common. So to solve this, I'm going to factor out what they have in common. They have a sine of x in common. So I'm going to factor out this sine of x. So this is really sine of x times something minus something, and that's going to be equal to 0. And so when you factor out a sine of x here, it's like what goes here times this is sine of x. And of course, that's the number 1. Then over here, something goes here times sine of x is equal to this thing above. So you're going to need a 2. And you're also going to need the cosine of 2x. And because you have two things, the sine of x and this thing, and you're multiplying together to get 0, what happens is you can break the problem up into two different problems. One, either sine of x is equal to 0, or 2, 1 minus 2 cosine of 2x is equal to 0. And so we can solve this equation on the left. So on the left, it's all ready to go. So sine of x is equal to 0. So I need to find out where the angle x is going to live. So remember again, all students take calculus. Now this one's a little bit tricky because this 0 is not neither positive nor negative. So it doesn't matter which one you choose as long as you're consistent. So let's say that 0 is positive. So if 0 is positive, that means the angle can live here because sine, cosine, and tan of angles in the first quadrant are positive, or it can live here, right? Because the sine of angles in this quadrant are positive. And to figure out the actual angle, remember we have to look back at that table, right? So let's, it's always good practice to do this table again and again. That's the only way you're going to memorize it. And so just keep writing it down. And if you do this about 10, 20 times, you'll have no issue remembering it. The problem is often students don't write it down, and then it is a big hassle to try to remember. So I have to remember sine of 0 is equal to 0. And so I get square root 0, square root 1, square root 2, square root 3, and then square root 4. And these are all divided by 2. So divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. Right, so when is the sine of an angle 0? Well, right here, this is 0, so the input is 0. And so when I draw this, I'll put an angle here, it's 0. And then also on the left-hand side, there's an angle over here, its reference angle is 0. And so my answer would be x equals 2. You can start at 0, and now you don't need to add 2 pi in, because if you add 2 pi in, you just go all the way back around. If you add pi, you get to the next answer. So I'll just say plus pi n. And again, n is an integer. Now you don't want all of these answers because you only care about the answers between 0 and 2 pi, so what we do is we just count them off. When n is 0, you get back 0. When n is 1, you have 0 plus pi, so you get pi. If n is 2, you get 2 pi, which is too big, and so you can stop, because if you do 3 or 4, it's too big also. But n could be negative, so if n is negative, this is negative pi. Oh, but negative pi is too small. You stop at 0. So you only get 2 answers from this part of the solution. But remember, there's a second part to the solution, so that was just when sine of x equals 0. Now we also have this trigonometric equation over here, so we're going to solve it. So what we can do is we can move over the 1, so take away 1 from both sides, and we get negative 2 cosine of 2x equal to negative 1. And then you can divide out by negative 2, and you get cosine of 2x equal to positive 1/2. And so now we can see the cosine of the angle is actually positive. So we can make our all students take calculus. So all students take calculus. And I can find the quadrants that the angle may lie in. So over here, it's the cosine of the angle is positive, so I see that it could be in this quadrant, but not over here, because only the sine of the angles in this quadrant are positive, and not down here, because only a tan is, but it could be in this quadrant too, cosine. So cosine of angles in this quadrant are positive. And so now I'm just going to draw the angle here, and I need to find the reference angles, remember. So the reference angle for this, they're exactly the same, so I have an angle here, and a reference angle there. And so what's this reference angle right here? Well, when is the cosine of what equal to 1/2? Well, here's 1/2. Oh, that's a sine. I need to make a new line here, right? So now I'm just doing the cosine of theta. I need to do the next line, the cosine of an angle. And again, it's real easy. It says square root 0, you start with square root of 4. You go square root 3, square root 2, square root 1, square root 0, all over 2, 2, 2, 2, and 2. And so when is the cosine of angle 1/2? Well, here's the 1/2, and above it I see it's pi over 3. So the reference angle must be pi over 3. Down here, also pi over 3. Okay, so I'm ready to find my angles. So again, I start at the x-axis. The first answer is actually pretty easy to write down. So let's write this first answer down. And be real careful, right? So usually we have x in here, but now we have 2x. So what we'll do is we'll write down 2x equals, because the angle is 2x now, not just x. And the first one was pi over 3. And of course, you can add any multiple of 2 pi again. So 2 pi n. N is an integer. And then let's also write down the second answer, and then we'll finish it off. So the second answer, we start here at the x-axis, and we go all the way around over here. And so the idea is go all the way around, so 2 pi, and then go back pi over 3, and then we can write down that angle. And so that's going to be equal to 6 pi over 3. So we multiply top and bottom here by 3, minus pi over 3. And so this is equal to 5 pi over 3. And so my second answer would be 2x equals 5 pi over 3 plus 2 pi n. N is an integer. Now I want to solve these both for x, and that's actually pretty simple to do. If you look here, you're multiplying by 2, so to move it over, we just divide both sides by 2. Or better yet, you can multiply both sides by 1/2, and so you get x on the left. When you multiply this by 1/2, you get pi over 6. Plus, when you multiply this by 1/2, the 2's cancel, and you get pi n. It is an integer. And a similar thing happens over here. So I'll multiply both sides by 1/2, right? So if you want, we could write this. Right? Multiply everything by 1/2. And so what happens is you get an x here. This becomes 5 pi over 6, because 3 times 2 is 6. Plus, and then the 2's cancel, and you multiply that by 1/2, and so you get pi n. And again, n is an integer. And since we only want these answers between 0 and 2 pi, we can start counting them off. So I'll start at 0. So when n is 0, this term goes away. And we just get x equal to pi over 6. And then when n is 1, you get pi over 6 plus pi. And so what's that equal to? That's going to be pi over 6 plus 6 pi over 6. So again, get a common denominator, which is just 7 pi over 6. So my second answer would be 7 pi over 6. Now this will turn out to be all the answers you get from this part, because if n is 2, you have 2 pi plus a number. And notice you only want to go up to 2 pi and not even including. So if n is bigger than or equal to 2, you're done. And of course, if n is negative, this number will be negative because it'll be pi over 6 minus pi. And so then that'll be too far to the left. So you're all done right here. And the same thing happens over here. So you let n be equal to 0. This term will go away, and we get 5 pi over 6. And then when n is equal to 1, right, that'll be plus pi, which is really 6 pi over 6. And so it'll be 11 pi over 6. And those are the answers that come from this that are just between 0 and 2 pi. Remember, if that's 2 again, it'll be 2 pi plus a number, which will be too big. If it's negative, it'll be negative pi plus this number, which will actually be too small. So you actually get 6 answers for this problem. 0 pi, pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. And you can check them by plugging them back into the original equation over here on your calculator and making sure you get out 0. All right, so the last thing I want to do real quick, I wanted to do a calculator problem so you can see how you can solve these on your calculator really, really quickly. So on your calculator, if you have it, it's real simple to solve these types of problems. We've solved equations before, but we haven't solved any trigonometric equations with our calculator. So what you want to do is you want to graph sine of x. So hit sine x. And that's it. Make sure again you're in radians. Hit your window button. Now it says find the solutions on the interval from 0 to 2 pi. So what we'll do is for x min we'll put 0, and for x max we'll put 2 second, and then pi, the raised to button, pulls up the pi. And that's all we care about. And then we'll do zoom and find zoom fit. You can just hit 0 if you want. And you get a nice looking graph. And what I'll do here is I'm going to copy this graph down. And so here's my graph. It looks like this. You can look right off of your calculator if you want. But I'm just going to copy it down. So it went up. It came down. That's the graph of sine of x. So I graphed the right. Oh, but I forgot to graph the left. So let's graph the left too. So enter. And so I'm going to graph the left-hand side, 3 over 5. Because remember the idea is graph the right, right? Graph the right side, graph the left side, and then find where they cross. Right, so here's the other side right here. It goes right through here. And I want to find where these two graphs cross. Namely, I want to find these 2 points. Right here and right here. And you do that with your calculator by using a button called intersect. And so if you remember, you just hit second trace to pull up the calculate menu and then go down to number 5. And what's nice about this is it's not too difficult to do. It says first curve, hit enter, second curve, enter. It's just if there's more than 2 curves, you have to pick the curves. And then hit enter for a guess. You can give it a guess. So maybe I want to find this first intersection point to begin with. And so hit enter, and it's going to spit it out. So on this one, you get 0.6435. So my first answer would be to 4 decimal places, 0.6435. And I'll put a comma to separate them. And that's a 5 right there. And then the second answer is what? So hit second trace again, number 5 for intersect. Enter, enter. But don't hit enter too quickly on guess because you got to scroll over to the second one, the second intersection point. It doesn't have to be right on it, but it has to be close to it. And this one's 2.498. And because that 5th decimal place is a 9, we'll make that a 1. So 2.4981. So down here, 2.4981. That's to 4 decimal places. And again, you can check your work on your calculator by plugging this into this original equation and making sure you get out about 3/5. Notice it won't be exactly 3/5. So if you take the sine of 0.6435, right, 3/5 is about 0.6. It's 0.59999, which is about 0.6, right? It's an approximation because you rounded it to 4 decimal places. So real quick, let's review what we just did. So we solved trigonometric equations 3 different ways. One, using the unit circle, which is really easy to do if you have a unit circle. But if you don't have a unit circle, you have to use the reference table. So you create this reference table using the reference angles, and that's what people typically do when they solve trigonometric equations if they don't have any sort of if they don't have a unit circle or technology or a calculator available. And finally, we used a calculator and a technique that we've seen before: graph the right, graph the left, and intersect.